This is second quarter lesson 2, the graphing polynomial function. So dito matututunan na natin kung paano mag-graph ng polynomial function at syempre sa tulong ng leading coefficient test, yung ating lesson number 1. Recall muna tayo ng some concepts about polynomial function. Polynomial function has all of its variables with exponents which are positive integers. So, ibig sabihin, lahat ng variable ng polynomial function ay may positive integer na exponent. Kapag nakakita ka ng negative exponent, hindi na yon polynomial function. At the same time, kapag nakakita ka rin ng fraction na exponent, hindi na rin siya polynomial function. Same kapag ka may radical yung variable at hindi mo kayang i-simplify. Let's check our polynomial function concept. So which of these are polynomial function? Let's have this first example. We have f of x equals x raised to 4 minus x raised to negative 2 plus 2x minus 9. So dito sa example na to, check natin kung polynomial function siya. Una, i-check mo muna lahat ng exponent. Dapat lahat ay positive. Pero dito, may negative ka na exponent ng x. So, ibig sabihin, this is not a function or polynomial function. Sa second example naman, meron tayong x na nakapasok sa square root. So, square root of x cannot be simplified. Hindi natin siya masisimplified. So, ibig sabihin, hindi rin ito polynomial function. Pero kapag may exponent niya na 2, pwede natin siya i-simplify. Pwede siya considered as polynomial function. Since 1 lang yung exponent niya, hindi pwedeng i-simplify. So, it means this is not a polynomial function. Sa third example naman, kung mapapansin, lahat ng exponent ay positive. So, ibig sabihin, this is a polynomial function. Sa next example, lahat din ng exponent ay positive. We have 4, dito naman 1, dito rin ay 1. So, ibig sabihin, this is a polynomial function. So, clear na tayo sa concept ng polynomial function. Kapag ang exponent ay lahat positive, check. That is a polynomial function. Let's have some basic features of the graph of polynomial function. So, ang graph ng polynomial function is continuous. This means that the graph of polynomial function has no breaks, holes, or gaps. Example, this one. This is a graph of a polynomial function since this is continuous. This one naman is not kasi meron siyang break. Yan. Naghiwalay. May holes. May gaps. Ayan, bawal yan. Hindi yan pwedeng i-considered as a graph of polynomial function. Another feature of the graph of polynomial function is it should be smooth and rounded turns. Kagaya nito, rounded turns. Yan, round yung turns niya. Kapag ka may sharp turn, kagaya nito, this is not a polynomial function or graph of polynomial function. These are some examples of a polynomial function. Kung mapapansin, smooth, continuous, and continuous, rounded turns, ayan, rounded turns, at continuous, no breaks, at walang sharp turns. Ayan, these are examples of the graph of polynomial function. Dito naman, ito ang hindi example of a polynomial function. Kung mapapansin, meron siyang gap and may holes. Tapos may sharp turns. So, hindi siya considered as polynomial function. Let's have some statement about polynomial function. It can be shown that for a polynomial function of degree n, the following statements are true. First, the function has at most n real zeros. So, na-discuss ko na ito before. I-check mo lang kung ano yung value ng n o yung highest exponent. Yun yung number of real zeros. It should be at most n. So, pwedeng mas mababa sa n or equal to n, pero wag lang siyang tataas sa n. Yung number of real zeros. Kapag bumaba sa n, ibig sabihin, yung mga zeros na iba ay imaginary or not real. Another statement which is true is the graph has at most n minus 1 turning points. So, turning points, ito yung kung saan siya iikot. Ayan, this is one turning point, another turning point, and another turning point. So, check mo lang din ulit yung highest degree. And then, bawasan mo ng isa. Yan yung maximum turning points. Pero, pwede rin siyang mas bumaba dun, kaya sinabing at most. Later on, i-discuss natin kung bakit siya pwedeng mas bumaba pa sa n minus 1 yung number of turning points ng isang polynomial function. Okay, now let's have multiplicity and x-intercept. X-intercept are the zeros of the polynomial function, and sometimes it has multiplicity. Ibig sabihin, nadodoble yung mga x-intercept. So, multiplicity of root r is the number of times the x minus r is a factor of f of x. So, kung ilang beses naging factor itong x minus r na to ng isang polynomial function. So, sabi dito, if the multiplicity is even, the graph touches the x-axis at r and turns around. So, kapag dalawang beses, 4 na beses, 6 na beses, or even number, yung kanyang multiplicity, dadaan daw siya, or dadaan siya dun sa r, at magto-turn around doon din mismo sa r, or kung saang zero siya dumaan. Another thing is, kapag odd number naman, yung number of multiplicity, like 1, 3, 5, and so on, the graph touches the x-axis at r. Ito ay kapag 1 lang yung multiplicity, touches, nadaan lang siya. Pero, magpa-flatten out kapag ang kanyang multiplicity is greater than 1, pero odd number pa rin. Magpa-flatten out siya near the x-intercept. Medyo mag-standby siya ng konti kapag greater than 1. Pag mas mataas sa 1, mas matagal siyang magpa-flatten or mag-standby dun sa malapit sa x-intercept bago siya magto-turn around. Yan yung concept ng multiplicity. Kaya minsan, nababawasan yung turning point ng polynomial function based kasi dun sa multiplicity ng isang factor of f of x. Example of multiplicity or graphing a polynomial function with multiplicity is this one. We have f of x equals 2 times x plus 2 quantity squared times x minus 3. So, dito, sa function na to, ang zeros natin is at negative 2, 0 to the multiplicity of 2. Dahil dito sa exponent na to. Ibig sabihin, twice siyang magiging factor or zeros ng polynomial function na to. Yung negative 2, 0 is a 0 of the function twice. And also at 3, 0. So, dito sa 3, 0, ang kanyang multiplicity ay odd number which is 1. So, check natin. So, dito sa graph na to, ang multiplicity ng negative 2 is 2. So, mapapansin, nag-touches siya sa x-axis at negative 2 and dun din siya nag-turn around. Yan, nag-turn around siya. Ibig sabihin, even number yung kanyang multiplicity. Nag-turn around. Kapag mas tumataas pa yung kanyang multiplicity na even number, mas medyo mahaba yung kanyang pag-standby dyan at bago siya mag-turn around. Dito naman, sa part na to, dito sa 3, 1 lang yung multiplicity niya. Kaya nag-pass through lang siya. Nag-touches siya dun sa 3 at nag-pass through lang siya dun sa ating x-intercept na 3. Kapag ka more than 3 yan, pagka more than 1 yung kanyang multiplicity, let's say 3 ang kanyang multiplicity, medyo magpa-flatten siya dito, malapit sa 3, bago siya magpa-pass through. Medyo kukurba siya ng konti pa ganun. Yan, later on, madidiscover nyo kapag nag-graph na kayo ng polynomial function. Bago tayo mag-graph, recall muna tayo ng end behavior of the polynomial function. So, ito yung pinaka-table natin. Ito yung even number itong dalawa. Ditong dalawa naman is odd number yung degree. Tapos, dito sa dalawa, ang leading coefficient ay positive. Dito naman ay negative. So, dito tayo sa una. Kapag ang degree mo is even, at the same time positive ang leading coefficient, yung graph mo will be rises to the left and to the right. Kagaya nito, parang yung kamay mo, parehas na nakataas. Ayan. Kapag even number at positive ang leading coefficient. Pag even number naman at negative ang leading coefficient, parehas naman na magfo-fall sa left and right. Parang kagaya nito, yung kamay mo, parehas na nakababa. On the other hand, kapag odd number yung degree ng polynomial function at pag positive ang leading coefficient, sa kaliwa naman magfo-fall at sa right naman magra-rise. Kagaya nito, parang yung kamay mo, ganyan ang itsura. Sa left nag-fall, sa right magra-rise. Kapag odd number ang degree at negative ang leading coefficient, ito naman ang itsura ng graph. Sa left side magra-rise at sa right side magfo-fall. Kagaya nito, pabaliktad naman yung kamay mo. Nag-rise sa left at magfo-fall sa right side. So, ito yung ating leading coefficient test. Kapag tapos may graph yung function, ganito dapat magiging itsura. Kapag hindi ganyan ang itsura, based on leading coefficient test, maybe medyo may mali ka dun sa pag-graph mo. Let's have some steps in graphing polynomial function. First step, use the leading coefficient test to determine the graph end's behavior. So, importante yon para alam mo kung paano yung magiging itsura ng graph mo. Pangalawa, find the x-intercept. Siyempre, kailangan alamin mo muna kung saan magta-touch yung graph mo at x-axis. Number 3, you need to find the y-intercept. Ito naman yung point kung saan magta-touch yung graph sa y-axis, wherein yung x natin dito sa y-intercept is always equal to 0. So, para ma-solve yung y-intercept, gawin mong x is equal to 0 and then simplify. Number 4, check for multiplicities. So, sa paghanap mo ng x-intercept, alamin mo kung ilang beses nagiging factor yung isang number ng polynomial function. Number 5 naman, use the fact that the maximum number of turning points of the graph is n minus 1, where n is a degree of the polynomial function. So, to check whether it is drawn correctly. Ayan, double check lang yung turning points daw. And number 6, locate additional points using table of values. So, pwede kang mag-assign ng mga possible values of x and then solve using the function para makapag-locate ka pa ng additional points para mas medyo accurate yung pag-graph mo ng polynomial function. Let's try to graph this function. We have f of x equals x plus 1 times x minus 2 times x minus 4. So, first step, the degree is 3 kasi we have 3 factors, 1, 2, and 3. So, nasa 3 degrees tayo or tatlo din yung zeros natin kaya naka-odd number yung degree natin. And sign of leading coefficient test, that is positive. Kasi dito positive, yung coefficient ng x, dito din positive, dito rin positive. Pag minultiply mo lahat yung tatlong positive, ang answer is positive pa rin. Next, yung zeros naman, pag in-equate mo to sa 0, Or pag kinuha mo yung additive inverse ng positive 1, this is negative 1. Dito naman, additive inverse ng negative 2 is positive 2. And additive inverse of negative 4 is positive 4. So, ang zeros natin ay negative 1, 2, and 4. Dito magta-touch yung graph natin sa x-axis. And ang y-intercept, of course, ang x dapat ay 0. So, from this function, palitan natin yung x dito ng 0. Dito rin ng 0, at dito rin ng 0. Tapos, i-multiply mo lang lahat yan. We have 1 times negative 2 is negative 2. Negative 2 times negative 4 is positive 8. So, 8 ang ating y-intercept, or at point 0.08 siya magta-touch sa y-axis. And ang end behavior, since we have positive na leading coefficient at degree na 3, it means the graph must fall to the left and rise to the right. And then, yung turning point natin is at most n minus 1. Ang n natin is 3 dahil ang degree natin ay 3. So, 3 minus 1 is 2. So, at most 2 turning points lang ang pwede nating makita doon sa graph. And let's have the table of values. Sa table of values, madali lang to. Kailangan mo lang mag-identify ng values of x. So, dito, this is assumption, o ako lang nag-assign nito. We have negative 2, negative 1, 0, 1, 2, and 3. Parang nagbilang ka lang. And then, para makuha itong mga number na to, parang kagaya dito sa ating pag-solve ng y-intercept, palitan mo lang yung x muna ng negative 2. Ipapalit mo dito yung negative 2 instead of 0, magiging negative 2 lang yan, and then simplify. You can use calculator para mas mabilis ka mag-simplify. Kapag sinubstitute mo yan, ganito yung kakalabasan sa baba. So, ibig sabihin, may mga ordered pair na tayo na pwedeng i-plot dun sa graph natin. We have negative 2, negative 24, negative 1, 0, 0, 8. Ito yung y-intercept kanina. We have 1, 6. We have 2, 0. Ito yung x-intercept natin. And then 3, negative 4. Another x-intercept is yung negative 1, 0. So, makakatulong tong mga set of points na to para mas ma-plot natin later on yung ating polynomial function. So, let us plot this graph. We have the zeros of the function at negative 1, 0. So, negative 1, 0, something here. And next, we have 2, 0. We have point here. And plot mo muna lahat ng zeros. And then, another one is 4, 0. Another point here. Next na ipa-plot is yung y-intercept. We have 0, 8. So, 0, 8 is here. 8 yung value ng y and 0 yung x. Then next, ang next na ipa-plot is yung mga point na nasa table of values. Yung negative 1, 0 na plot na natin. Same with 0, 8. Yung 1, 6 na lang. 1, 6. So, 1 yung x and y is 6. So, something here. Yan, plot natin siya dyan. So, that is another point. Then, we have 2, 0 na plot na natin. Then, next, we have 3, negative 4. So, 3 ang ating x and negative 4 ang ating y. So, bababa tayo dito ng konti. Yan, sa tapat ng positive 3 at sa tapat ng negative 4 na y. Ayan, so, na-plot na natin yung mga graph or points rather. Now, yung end behavior ng graph natin is, kagaya niyan, yung sa kamay, sa left side na sa baba, sa right side na sa taas. So, start tayo sa babang baba. Medyo sa baba, sa left side, pababa daw siya. So, drawing na lang tayo dito ng paganyang line. Yan, paganyan siya. So, lagyan mo na lang siya ng arrow, means it is extended. Tapos, curve dito sa y-intercept. Kasi magta-turn siya dyan sa y-intercept. Yan. And then, straight siya dito sa negative 1, 0. Then, next, continue natin papunta dun sa next point. And then, magpa-pass through siya dun sa another zeros. Yan. And then, diretso tayo sa baba. And then, magta-turn siya dito. Then, next, continue dun sa another zeros. And then, straight line. Lagyan mo lang ng arrow. Ayan. Ganyan yung magiging graph niya. Bare lang dun sa handwriting ko, freehand. Medyo mahirap mag-drawing dito sa graphic tablet. Ayan. Pero smooth dapat yan. Kapag magdo-drawing kayo, it should be smooth. Dapat yung pagkaka-curve. Kagaya kanina. So, kapag i-drawing mo yan, nang walang mga sharp, pag ganito dapat ang itsura ng graph niya. Ayan, pag ganyan dapat yung line niya. Smooth. Ayan, ganyan ang itsura. So, bare lang na sa drawing. Let's have another example. We have f of x equals x plus 1 times x plus 2 quantity squared and x minus 1 quantity cube. So, check natin yung degree. Ang degree natin ay 6. Bakit? We have 1 here, we have 2 here, and we have 3 here. So, i-add lang natin. Kasi pag nagmumultiply tayo, we're just adding the exponent. So, we have 3 plus 2 plus 1. So, ang degree natin ay 6. The next, yung sign of leading coefficient natin is positive pa rin. Kasi we have here positive, positive, and positive. So, pag minultiply mo yan, positive pa rin yung kakalabasan. The next, yung zeros natin, dito, pag kinuha mo yung additive inverse, this is negative 1. Dito naman is negative 2. Dito naman is positive 1. Pero check on the multiplicity. Yung negative 2 has multiplicity of 2 dahil sa exponent na to. Yung positive 1 has multiplicity of 3 dahil sa exponent na to. So, we have negative 1, negative 2, multiplicity of 2, and 1 multiplicity of 3. Another thing is we have y-intercept. So, again, yung x natin, papalitan ng 0, and then simplify. So, we have 0 here, 0 din dito, and 0 din dito. So, parang simplify mo lang yan. 2 square is 4. Negative 1 cube is negative 1. So, negative 1 times 4 is negative 4 times 1 is negative 4. So, negative 4 ang ating y-intercept. Or at point 0, negative 4 siya dadaan sa ating y-axis. Then next, ang end behavior, dahil positive ang leading coefficient at ang degree natin ay 6, which is even. Ang end behavior natin is rise to the left and rise to the right. Dahil even yan at positive, parehas napapanik sa kaliwa or sa kanan. Then next, yung turning point natin is n minus 1. We have 6 minus 1 kasi yung n natin ay 6. And it should be at most 5 ang ating turning point. So, pwedeng mas bumaba sa 5. Depende sa multiplicity natin. Then, of course, yung table of values, mag-assign ka ulit ng values of x. Ang nilagay ko dito is negative 2, negative 1, 0, 1, and 2. Wherein yung negative 2 tsaka negative 1, this is zeros of the function. So, 0 na yung kanyang y. Same with 1. Zeros of the function na rin yan. So, 0 na yung value ng y. Dito naman sa 0, negative 4, this is the y-intercept. So, dito, para makuha yung 48, palitan mo lang yung x ng 2 from this function and then simplify. Ito yung mga point na makakatulong para i-plot natin ng maayos ang ating polynomial function and at the same time yung ating end behavior. Now, let's plot the function. First, locate natin yung mga zeros of the function. Locate natin ang zeros of the function. We have negative 1, 0. So, plot natin ang negative 1, 0 here. Ayan, ito yung negative 1, 0. Next, we have negative 2, 0. Ayan, we have here negative 2, 0. And another one is 1, 0. Ayan, dito naman yung isa. Then next, na-plot na natin yung tatlong zeros. Yung y-intercept naman, we have 0, negative 4. So, 0, negative 4, ito ang ating y-intercept. Next, meron pa bang pwede i-plot? Okay, so yan na yung magiging itsura niya. So we have next yung multiplicity daw natin. Pagdating sa negative 1, isa lang yon. Pagdating sa negative 2, dalawa. So medyo mag-turn siya dun sa negative 2. And sa 1 naman, multiplicity of 3. So medyo mag-standby siya ng konti dun. So kung i-check natin yung graph sa taas, sa left side, manggagaling siya sa taas. And then sa right side, mag-e-end din siya sa taas. So starting from negative 2, multiplicity of 2 daw siya. So ang gagawin natin is, starting from the upper part, draw tayo ng line papuntang negative 2. So magmumultiplicity of 2 doon, so magta-turn tayo siya. Yan, pag ganun siya. And then, babalik ka papuntang negative 1. Ayan, daan ka ng negative 1. And then, bababa ka hanggang negative 4. Then, next, papanik ka dun sa 1. Dahil multiplicity of 3, medyo magi-standby ka ng konti. Malapit dun sa 1. And then, panik ka na sa taas. Yan, ganyan itsura niya ng graph. Medyo nag-standby siya dito sa sa positive 1. Yan, pag ganyan yung graph niya. Yun. So, parehas siyang pataas sa left at sa right side. Yan, magiging ganyan ang itsura niya. Yan ang itsura ng ating graph.